Hello everyone, my name is Mihaela Ștefan. I am a professional services engineer at Infinet Wireless. Thank you very much for taking the time to join us. Today we are going to discuss about the common errors that are performed when installing or configuring the Infinet devices. Solutions will be provided in each case in order to ensure a proper functioning of the devices. The webinar will be divided in two parts. The first part describes the typical errors made during the installation of the devices, and the second part shows the usual errors that are performed during the configuration. Let's begin with the review of the physical configuration. The most common reason for equipment failure is the missing or the improperly performed grounding. Very often, the grounding of the devices is not performed at all, or the grounding cable is attached to the rack. It is a common misconception that if a shielded FTP cable is used, it distracts the noises from the device, but it actually doesn't work this way. First, the shield of the FTP cable gets in contact with the RJ45 connector only on the side of the indoor unit without touching the outdoor unit. Secondly, the screening of the FTP cable does not have sufficient properties to effectively dissipate the noises. So even if you use shielded metallized connectors on both sides of the cable, which is also a mistake, this will not provide sufficient level of lighting protection. In case of a lightning discharge, as you know, the current is over hundreds of amperes, and a simple contact connection will not withstand the charge load. As a result, the components of the board will be burned, and you have to replace the product. For a proper lightning protection, you need a complete match between the length of the Ethernet cable and the length of the grounding cable, as you can see in the picture. In this case, the main EMF power from the lightning discharge is shunted through the bolt and the grounding cable, and not through the Ethernet cable. To recap, the wireless device itself, the lightning protection devices, the power injector, and the internal switching equipment must be grounded separately. Each external unit must be grounded with a separate cable that has a cross-section of at least 4 millimeters, and the grounding cables should be laid along the length of the FTP cable and connected to the grounding circuit. The second mistake we have identified is the use of shielded metallized connectors on both sides of the FTP cable. Due to the difference in potential between the outdoor and the indoor unit, such an installation may damage the wireless unit. In addition, if you attach a shielded connector to the outdoor unit, the cable's screening can act as an antenna and radiate into the air. This can be noise coming from the reference oscillators, from the power supply, or from the Ethernet controller, for example. The shielded connector that is attached to the power supply is designed to reduce the emissions of the Ethernet signal and to prevent it from external interferences. This is its actual scope. Also, the RJ45 connectors must be properly crimped. An improperly crimped connector may damage the port on the device. A couple of years ago, we had a webinar where we described the installation and the grounding of all the devices in detail, and I will share the link into the chat section and in the description of the video as well. Also, we recently published an online course about lightning protection that is available to you on the Academy's portal. I would also like to dwell on the pressure equalization system. In all modern Infinet devices, the pressure equalization inside the devices takes place through the exchange of air with the indoor via the FTP cable. When the outside pressure rises, the device begins to draw air from the Ethernet cable. If the cable is damaged, water can get inside the device, and it will most likely cause it to malfunction. Additionally, if there are kinks in the cable, the air exchange will be difficult and the device will be exposed to an increased pressure. So make sure not to excessively bend the cables. It is important to monitor the condition of the cable and to use corrugation pipes for protection. The pressurization leakages can also occur as a result of an excessive or an insufficient Ethernet cable diameter. Please remember that the value of the outer diameter of the cable must not exceed 7 millimeters, and that we recommend using a cable of at least Cat5e category. Another problem with the FTP cable may arise as a result of the improper cable gland assembly. It is very important to first insert the RJ45 connector into the port, then screw on the gland body, and only then tighten the cable gland nut, as you can see in the left picture. If the gland is completely assembled on the cable, as indicated in the right picture, and then screwed into the device's enclosure, the FTP cable inside the connector will be twisted, which will affect its characteristics and durability. Therefore, please avoid performing the connection as seen in the right picture. Moving forward, when using devices with N-type connectors for an external antenna, before connecting the device to the power supply, please ensure that there is the same attenuation level added for both connectors. You should either connect to an external antenna or use attenuators with an attenuation of at least 50 dB. Also, remember that it is forbidden to turn on the device with an antenna connected only to one polarization. Another issue concerns the powering of some older platform devices. Some of these devices cannot be powered with direct current if the voltage is negative. I am talking about the H11 platform that includes the R5000 SMN and LMN devices. If it is necessary to power such devices in this described situation, we recommend to use the IDU CPE DC power supply, which was specifically developed for them. The use of IDU LAG and the AUX ODU INJG is possible for these devices only with a positive voltage. Otherwise, it may lead to device failure. In conclusion of our conversation about the installation, I would like to also mention the situation when the devices are powered up by a PoE switch. Some of our devices can be powered through power over Ethernet supplied by the switch port. However, we cannot guarantee a smooth operation using this setup due to the different standards implemented by each vendor. Therefore, we recommend to use the Infinet power injectors that are supplied together with the units. When powering the devices via the standard power injector, it is important to turn off the PoE on the Ethernet switch port, as you can see in the picture. Otherwise, there is a risk that the Ethernet port will flap, violating the integrity of the transmitted data. Let's now move on to the typical errors that occur during the configuration of the devices. For this purpose, I will switch to the view of the web interface of our Infinet devices. Okay, we are now on the web interface of our devices. One of the simplest but not rare errors is the incorrectly set value for the bitrate and for the output power. During the antenna alignment, in order to easily connect the devices, we recommend to set the bitrate parameter to the minimum value. I mean, this time for the XG devices and for the Quanta series, we are talking about the maximal modulation, which should be set to a minimum value when performing alignment. And in case of the R5000 devices and Evolution, we are talking about the bitrate, which should be set also to the minimum, and the automatic adjustment should be disabled. After you perform the alignment, however, it often happens that people forget to restore the settings. I'm going to tell you the recommended settings, which are to set the maximum value for the bitrate and modulation, and to also enable automatic adjustment, okay? This ensures that the link does not interrupt every time the parameters of the radio link do not correspond to the values that are required for the transmission on a particular modulation, okay? So you will have continuity in the data transmission, even if the radio conditions deteriorate. A similar situation is with the output power, because it must be set to a minimum during the preliminary configuration in the lab. As you can see, it is set to minimum for configuration. But after the installation is finished, you should usually set it to the maximum value or to the maximum allowed value in your region, okay? And also enable automatic adjustment, because this will adjust the output power level in real time and will thereby extend the life of your device. Next, on the R5000 devices, when using the software that supports the polling technology, if the polling mode is disabled, then the devices will use the CSMA-CA technology to access the medium, which leads to a low efficiency in using the medium resources. Okay. In addition, it contributes to a high number of errors and retries in case of a hidden subscriber problem, when there are subscribers of the same sector that cannot hear each other. So we strongly recommend to enable polling. Next, I'm going to talk about the air updates. This is another aspect that is related to the R5000 and to the Evolution series. If you activate over-the-air updates, the exchange of information about software versions and the automatic updates may cause problems when they are improperly configured. Okay, you can set here the active mode, for example, or you can enable over-the-air updates from the maintenance section over here. Okay, and your devices can be automatically updated. However, you must take care to the actual architecture of your network. Because if your architecture does not permit it, you will have situations when if one device updates its software, it will cause a restart of all the nodes in the network and loss of communication throughout the entire network. Okay, so be careful how you configure the active mode for the over-the-air updates. Let's now switch a little back to the presentation. Let's take a look at a number of common mistakes that are performed when setting up the synchronization. If the devices located on the same site are synchronized by the AUX ODU sync unit, all the devices, including the slaves, must use the TDMA-based software version. It is also mandatory to set fixed values for the frame size and for the downlink-uplink ratio, and these values must be the same for all the devices. In practice, the automatic frame size selection isn't usually turned off, and the radio field is often left empty, which leads to a missing synchronization, so the sectors will interfere with each other. Additionally, when synchronizing two devices on the backbone, the uplink-downlink ratio should be set to 50-50, otherwise the data transmission will become ineffective and with a high level of losses. This scheme shows a faulty configuration. In case that the downlink-uplink ratio is set, for example, as 80% to 20% as indicated in the picture, the traffic coming from the slave 1 device uses 80% of the frame, but the master 2 device can only transmit to the slave 2 device in 20% of the frame. As a result, the packets will overflow into the master's output queue and are dropped. The next popular problem is the missing or incorrectly performed radio planning. When mounting several devices on the same rack, it is important to implement both space and frequency diversity with a guard interval that should be equal to the channel width. A common scenario is the installation of several base station sectors back-to-back on one rack. The base station sectors will interfere with each other because they will hear the signal of the neighboring sector better than the weaker signals from the subscriber terminals. If a synchronization device is not used, you need to provide frequency diversity. In this case, the guard interval is equal to the used channel width as mentioned. So for a channel width of 20 megahertz, this setup requires the utilization of 140 megahertz, which is quite inefficient. If the frequencies are reused within the same site, it is necessary to use a synchronization device. Otherwise, the mutual interference of adjacent sectors will lead to the degradation of the link. It is important to implement the ABAB scheme so that the devices operating on the same frequency are mounted back to back. This is recommended because the radiation from the back lobe is smaller compared to the one from the side lobes, and the back of the device will also introduce an attenuation to the interfering co-channel signals. The guard interval in such a scheme can be reduced to only 5 MHz, so it indicates a very efficient use of the spectrum resources. Let's now switch back to the devices. We will now discuss about the management configuration. In the past, we recommended the configuration that I am going to show to you right now. Let's first remove the management from this switch group. Okay, and I will create a new switch group for management, let's say 10, okay. To it, I will add the Ethernet and RF ports. And then I will create L3 management, which automatically creates an SVI interface attached to switch group 10. The next step was to create a VLAN interface. We'll call it also 10, which will have as parent the SVI interface, okay. And then we set the VLAN ID for the management, which is 10, and we recommended to set the IP over here. The next step was to add a rule in the switch group to filter only traffic that comes tagged with VLAN 10. In our case, since the first switch group does not have a filtering rule, it is also advisable to place it as the first one, the switch group. Okay, this is an older configuration, but now in the past few years, we recommend to use a different configuration, which is more efficient, more simple, and more secure. So I will show you the new configuration that we recommend. For this, I will remove the actual configuration and continue with the new one. Okay, remove rule. Then I'm going to remove the group and we'll create it from scratch. First of all, let's create the switch group. We'll call it also 10. And now the difference is that I will create a VLAN interface. Okay, the Ethernet interface this time. We specify the VLAN ID and we configure no IP address on the VLAN interface, okay? We will configure it on the SVI interface. Now, going back to the configuration of the switch group, in the switch group, this time we have to add the RF and the VLAN ports and not the Ethernet port, because the Ethernet port was specified as the parent of the VLAN port. We do not have to add any rule at this point. I will just hit create L3 management when an SVI interface will be automatically created and attached to the switch group 10. And we recommend to set the IP address on the SVI. Okay. Okay, so this is an example of how you should configure the VLAN-based management access these days. This scheme has several advantages. The management switch group position in the list of groups does not matter. All traffic incoming in the specified VLAN will automatically enter in the required group, regardless of the rules of the other groups. Also, as you saw, there is no need to configure rules in the management group, so it is simpler. Please also note that the management traffic is transmitted through the radio segment untagged. So if it is necessary to restrict the management of the remote devices through the wired segment, no additional settings are required. It is enough to create a group with the corresponding number and add to it only the radio interface. This scheme is more flexible and more secure, so we recommend to update the configuration of your devices if necessary to the new scheme. Let's move on and discuss about the switch group configuration. I have configured here two different switch groups with different rules, so we can analyze what happens. Please note that the switch groups are processed in the order in which they are placed, and the same is valid for the traffic filtering rules. Therefore, it is important to set the correct order when you create them. For example, we have a group that allows traffic from a range of VLANs from 10 to 20, and there is also a switch group which should contain traffic from a specific host and coming through the Ethernet 1 port. Okay, this is only the traffic that comes from a specific host. If, for example, the traffic that comes from this host is also tagged with a VLAN that is listed in this switch group, all the traffic will be actually put in switch group 1, even if the switch groups have different rules. And as expected, it will not be routed to the destination. Okay, it will not reach the destination. So please be sure to configure the correct rules and the correct order in the groups, because the rules and the switch groups are checked sequentially in the order in which they are added. I also want to mention here that the trunk mode logic on the R5000 and Evolution devices is a bit different from the logic of the other vendors. Most often the trunk mode is activated in the switch groups on both sides of the link, which is unnecessary, although it will not cause the interruption of the link. The trunk mode is used on these devices in order to add several VLANs corresponding to different customers into a single switch group. This eliminates the load in configuration, because otherwise a lot of switch groups should be created for each customer. Such a scheme with the trunk mode activated is described in detail in our documentation. Our next topic concerns the frequency grid limitation. There are sometimes situations when devices select the frequency automatically using the DFS or instant DFS technologies. And during the initial setup, it takes a lot of time for the master to scan all the frequencies and to select the least loaded one. Then the slave device has to also find the master's operating frequency, and it will also take time to scan. In order to save time, we recommend to limit the frequency grid. And for example, you can scan the air using the spectrum analyzer and select the least interfered band available. After you determine the least interfered band, you can perform limitations from the frequency grid. Okay, for example, if you are using the 20 megahertz bandwidth, you can limit from, let's say, 5,500 to 5,700. So you limited the scan search only to 200 megahertz instead of about 2 gigahertz. This should spare a lot of time in the link downtime, initially when the setup is performed. Now I want to talk about, a bit about the PRF interfaces. PRF interfaces can be added from the network settings section over here, create PRF. Okay. Usually they are created to extend the mint capabilities over the wired interfaces. So the PRF interface will always have as parent a wired interface, the Ethernet interfaces. And when you configure it, you have to go to the link settings sections over here. Our PRF interfaces that was just added appears here. We need to enable the link to configure all the details here, but I'm not going to do this right now. It's just to show you an example. And very important to join the RF and PRF, okay? Usually they are not joined. They are like this. And you have to add join and join them, okay? So this allows you to extend the mint area of over the wired interfaces. Let's switch to the presentation mode, because I want to tell you more technical details about this. When combining the devices into a single mint area using the PRF interfaces over Ethernet, as you can see, you will be faced with the problem that loops will appear. If the PRF and the RF interfaces are joined, from that moment, they logically begin to behave as one interface. Let's take a look at the scheme and see what happens in this case. PC1 does not know initially the MAC address of PC2, so it generates a broadcast ARP message to discover it. During the broadcast transmission, loops will occur, and I will explain why this happens. All the process is also described in our documentation, so you can review it. First, the broadcast packet reaches the switch, which forwards it towards all its ports except the one through which it received the frame. Then master 1 and slave 2 will receive the broadcast and generate unicast min frames for all the nodes in the mint area. Please note here that mint does not use broadcasting internally. Next, slave 2 receives the unicast copy of the ARP from master 1, for example, through the PRF, and switches it to the external network through Ethernet 0 port, reaching back to switch 1. Switch 1 will broadcast toward master 1 and PC1, and the process is repeated endlessly. This describes the clockwise loop, but similarly, a counterclockwise loop will be created. Moreover, other loops are formed between all the units, as indicated by the red line in the picture. This kind of loops will create in just a few days a full load on the units and congestion is reached. It is a common mistake for people to connect several units to the same switch and create loops because of misconfigurations. Fortunately, there are a couple of solutions available that you should always keep in mind. The first solution is to exclude the Ethernet port from the switch group at master 1 and slave 1. This solution is very simple, avoids loops and creates no overhead. However, the disadvantage is that master 2 becomes a single point of failure. If it fails to operate, master 1 is forbidden to access the external network as it does not include the Ethernet port, and there will be an outage. The second solution is to enable STP on all the units. This configuration avoids loops and single points of failure, but it is a complex protocol, and if it is misconfigured, it can create many problems in your network. So it is advisable to use unmanaged switches or switches that forward STP transparently and enable STP on all our units. At the end of our webinar, let's take a look at a number of mistakes that are made when using the failover function. Failover or link redundancy can be implemented in two scenarios. The first is the one presented above in the picture, and its particularity is that it uses third-party equipment for the redundancy path, usually a wired interface being implied. The second scenario uses a wireless link as failover, made up of devices from the R5000 or the Evolution families. The principle of operation for the failover mechanism is very simple. PRF interfaces have to be created on the wired interfaces in order to extend the mint area and have visibility over the different transmission paths and their associated costs. In the first scenario, we always use the manual configuration mode where we configure the failover function on the master device and specify the MAC address of the remote node to be monitored. The master device will just have to listen to the MAC address of the slave, and if it seizes on the main path, it keeps it active. Otherwise, it switches to the backup path. However, errors most often occur when deploying the second scheme that uses Infinet devices on the backup path. Please note that in order to avoid loops, you have two options. You can create different switch groups on the links, as you can see in this first picture, or you can use the switch border function on the PRF interfaces of the devices on one of the links, as it is indicated in this second picture. If you want a certain link to be the main one, then it is necessary to use the manual failover mode to force it to be the active one. But if you want the link with the best radio conditions to be selected as the main one, you need to use the automatic mode on both masters. In this case, please do not specify the MAC address of the remote nodes, otherwise the scheme will not work. I will now switch shortly to the web interface to show you that in the latest beta version, the failover setting was added to the web interface as well. As you know, it was configured until now from the command line. In the link settings section, you now have the possibility to configure Mint failover. And if you specify the MAC address of the remote device, you are configuring manual failover. And if you leave it empty, automatic failover will be implemented, okay? So it is now simple to configure it from the web interface, but all the commands are still available in the command line and you can use whichever configuration mode you prefer. This is what I wanted to present to you. I hope that now you are aware of the common mistakes and also know how to avoid them during installation as well as during configuration. Now, if you have any questions, please feel free to write them down in the chat section and I will answer them shortly. In the meantime, let's have a short break and thank you very much for your attention so far. We only have one question so far. If we recommend to use the TDMA software and what if the unit cannot accept use this software. All our units besides the R5000 series use by default the TDMA version, which is the only one available. In case of the R5000 series, you have to choose between the polling-based software and the TDMA-based software. And the recommendation is to use the one that is best fit to your needs. Because, for example, if you have enough spectrum available, the polling software might work better, might achieve a better performance. But otherwise, if you have interferences and you need to use synchronization, you are forced to use the TDMA-based software version, okay? So what I was telling in the webinar was actually that if you choose to use external synchronization via GPS, then you are forced to use the TDMA software version because you are not, you cannot use polling in this configuration. But otherwise, if you are not using an external synchronization source, you are free to choose between polling and TDMA. Another question is that for a Quanta 5 link, which is between the main control center and the sub control center, how can one determine which site should be the master and which should be the slave? First, I want to mention that from the transmission point of view, it does not matter which one is the slave and which one is the master, because the communication will take place with the same quality. But from the management point of view, it is logically to select the master, the device to which you have direct access. For example, if your computers for management are connected behind the main control center, you should put the master here. Otherwise, the master in the other location. Because when you perform changes on the master, for example, on the unit to which you have direct access, you can export the changes and it is easier to perform configuration changes to directly connect to the units, okay? So just from this point of view of the management, it is more logical to choose the master closer to the management point. I see there are no more questions. I will end the session for today. Thank you once again for your time. And I hope to see you again during our next webinar. Have a nice day, everybody.